Welcome to MyProjectBazaar.com. Task allocation for wireless sensor network using modified binary particles for an optimization. Abstract. Let's we discuss about the abstract. Wireless sensor network are a network of autonomous nodes used for monitor an environment. Developer of wireless sensor networks faces challenges that arise from communication link failure, memory failure, and computation constraints and limited energy. Wireless sensor networks have been successfully adapted in many strategic applications such as target tracking, surveillance, and classification. Coverage and the target direction probability are the two most significant factors for the performance of wireless sensor networks, which are determined by dynamic deployment algorithms. In initial deployment, randomness is often adapted, which, however, always does not lead to effective coverage. The effectiveness of wireless sensor networks depending on coverage and target detection probability provided by dynamic deployment. Applications for wireless sensor networks may be decomposed into the deployment of tasks on different sensor nodes in the networks. The task allocation algorithm assigning these tasks to specific sensor nodes in the network for execution. Given the resource constraint and the distributed nature of wireless sensor network, existing static task scheduling may not be practical. Therefore, there is a need for an adaptive task allocation scheme that accounts for the characteristics of wireless sensor network environment, such as unexpected communication delay and node failure. In this project, the system proposed a modified verification version of binary particles for an optimization for task allocation. Data flow diagram. Start the program and then initialize the network size and put the number of nodes. Here we used because put the swaram size means put the number of nodes here we used, and then if the check the conditions, if the node is greater than 0, start and select the source node and select the file. If we want to transfer the file, that file is selected here, and then activate the swaram optimizer. Here the Swaram optimizer used to get the current position and velocity and cost to calculate the best position and cost. If this used to allocate the task for each and every node of the swarams, and then transfer the file from destination to source to destination. Here Swaram optimization used to analyze the position and speed of the velocity to get the best position and their cost. Here in this project we used modified binary Swaram optimization and then display the performance analysis bar graph. How to reduce the cost in existing system and proposed system. Comparative graph are displayed. Discuss about the running procedure. Control F5 and the program, and here task allocation for wireless sensor modified binary particles for optimization. First we check the which display the system details, network settings are created, and then node settings. And those param size means here number of nodes in this product used are that are presented here. Example I want to show the 12. If you want 15 or anybody else, and then find the next, continue to the next program, and then select the source node. I am selected node 11 is the source node, and then select the file. If you want to transfer the file, that files are selected here, and then files are split into packets, and then param size. IP address secure. Here is IP address means the source IP address, source memory, and MAC address, date and time, and joules are created. And then this is the Swaram particles. In this node is the red color circle node is the server node. And then function, here we have the pumps function, and iteration with a constant location based cost, minimum value, maximum value, all are here. Then start the Swaram. Here moving the Swarams particles are all are calculated the minimum iteration, number of iteration here we take, and the minimum cost and the xy positions are all are recorded, and then calculate the best cost and minimum value and maximum value for the Swaram process. Then continue, we check the particle position and best position. First we calculate the particle position, and then unless the best position of the particles. Continue, modified binary particles optimization velocity used to calculate the velocity, and used to calculate the cost. This process is take a few minutes, so we are waiting the process. Here we display the modified binary particles optimization velocity, and then calculate the modified binary particle optimization cost. It will take the calculate to display the cost, and then continue. We calculate the best position and best cost, total iteration, energy levels, all are, and then file details, node and sync, virtual server, and then in here file transfer successfully can take, and then graph performance graph used to analyze the performance of the project. And here source to destination cost, all cost here take, these are displayed here. Thank you.